Alright, hello and welcome back to this whole coding thing. So today, I think I'm going to do a pretty quick thing because it's really late. I don't think you can see the clock, but it is really late. I was looking at the code and I found this little to-do here, and it was on my list as well. Before rendering, we have to compute these acceleration structures, which is like a bounding, BVH is short for a bounding volume hierarchy. And we have to do that for each mesh that we want to render. And then after that, there's some other steps like building a top level BVH of these BVHs. So you can find the right BVH and then traverse that. Basically, it just makes finding the ray mesh intersection way faster. So we have to compute these beforehand, and right now the way it does it is on a single thread. So we call this compute acceleration, compute accels function somewhere, and then we just basically do them one by one. And what I want to do tonight is to parallelize that. We have a nice little thread abstraction here, so we'll just try and use that and see if we could make it a bit faster. So first, we should do a little benchmark. So we just load up like the HDR JSON. I seem to use this scene quite a lot. It's a nice simple test scene. We don't really care about the sample count since we're not looking at rendering today. We're just looking at the setup time. So we just run that, and there we go. You barely see it, but here we go. So we're loading up the meshes. We got 5 meshes in this scene, and then computing BVHs. That took 464 milliseconds, and that's, yeah, it just does them one by one. And in this case, I think that the Venus, the statue. Let's show you this. Little statue here is probably the biggest mesh here. It's just got the most triangles. But anyway, we want to run this task in parallel. So let's try and do that. So if we look in renderer.c, how we set up the threads for rendering, basically we have this global. Well, it's not a global, it's passed in, but the renderer object, which contains pretty much everything kind of in like a hierarchical way. So in state, we have the render threads, which is a custom CR thread struct, and then these custom thread states, which actually contains the stuff we care about. So we're going to try and sort of use a similar approach for this. These are kind of ad hoc for now. We don't have like a real task system like some fancier game engines and stuff have. So we're just gonna kind of go to it. I don't think it's gonna be too complex. So okay, so I guess first we want like a struct for this, so we can actually store the data that we're processing. So like BVH build attack. And this is gonna contain like a BVH, and it's gonna contain, we get in the polygons and the poly count. So polygons struct, no, that's gonna be int polygon count, like that. And these might be able to be const, I think. Are these const? These should probably be const, right? We won't worry about that now, but these should be const. So there's a little thing. Then we want to set up like a few threads. So oops, seem to not be able to type tonight. So I guess we don't have the system configure thread count here, and in any case, if we have like one object, then it would be dumb to use like 10 threads. So I think we're just gonna default to mesh count for the thread count. Yeah, we'll do that. There we go. Then we'll set these up. Mesh count, and then we will T is struct 0. I think it was something like this. Let's see here. Actually, we can bring it up here. There it is. Yeah, there we go. So we just kind of do this kind of thing. We just prepare the threads, and yeah, we need the data for it as well. So we'll set that up first. BVH build tasks, similar kind of thing. Size of tasks, and then we'll do the same kind of loop. Hash count, and then tasks T will be BVH struct BVH build task, and then the BVH will be meshes T dot BVH. Then the polygons will be meshes T dot polygons. These are all just pointers, and then we'll just copy the poly count value. And this gonna be meshes T dot poly count. It's not happy about that. Oops. That's not valid syntax in this one. There we go. Does not refer to polyg count. That's not right. Okay, there we go. So we set up the tasks, and then in here we will pass in the. So yeah, now we're gonna follow this kind of thing. Actually, yeah, we could do this in one loop, couldn't we? I don't know why we have two loops. Yeah, we could just do this. Yeah, I don't know why I decided on two loops. I guess it was clearer at the time. But there we go. We set up the task, and then we pass it in. So threads. Hold on. Build threads T is, and then we pass in the thread func. It's going to be this. Yeah, we need the function, of course, for building the thing. So this will allow us to format like here, render thread, void star, BVH build thread. It's going to take a void star argument. This is going to be the actual code. So this is going to be BVH build thread. Xcode always auto-completes the parens for function pointer stuff, but I don't know what does that. And then, where were we? We need the user data. Yeah, so it used to be that CR thread contained all the parameters that the thread needed, but then I just separated them out because it should be like a generic thread dot. Let's see, dot h. Yeah, it's a pretty generic thread implementation. This just wraps, if we're on Windows, we're going to use the Windows thread API, then otherwise pthread. It's a very simple little wrapper. So, user data is going to be, do we cast that? Take the address, yeah, okay, yeah. Tasks T. Is that, yeah, that's good. Is that all? Yeah. Cool. And then we can start the thread, right? Yeah, we'll just set up a bunch of data and then, yeah. Okay. Start thread. Threads, this is going to be address of tasks T. It's a bit confusing, the terminology. We have tasks and threads, but whatever. I'm just copying what I did before. Yeah, if it returns non-zero, then we have some goofy. This shouldn't happen, but failed to create zero. BVH build task. so we know where we are. Else, we don't need to keep track of. Yeah, these are gonna exit pretty quick. And then in here, after this one is done, while loop. Okay, we'll worry about that in just a second, how the actual thing comes to an end. But anyway, now we want to build the thing. Oops. So this should be, so let's first of all get the BVH build task is struct BVH build task arg, like that. And then let's get this set up. Task.bvh is build bottom. Now I'm praying that build bottom level BVH is thread safe, because I didn't verify that before I started recording. Let's hope for the best. And then task polygons, task poly count. Let's just log that. Actually, log R is not thread safe, so let's not log. Right? Is that good? Incompatible pointer. Start thread BVH build. Oops, tasks. We want build threads. There we go. And yeah, we set the task and the thread func. Cool. Non-void function. See, we don't really return anything. What do we return in render? Return 0 from a void star? Yeah, I guess we can just return null for post-starter, whatever. Okay, that looks like it makes sense. We'll worry about the timer in just a second. I wonder if I run this, will it crash? I'll just do like that. Let's just rerun it. Let's see, make, and yeah, that was good. Compile and run. I don't think it crashes, which, yeah, that's fair enough. I think it crashes after top level BVH. Yeah. So we don't fetch the actual stuff back, right? Is there a good way to do this? We need to worry about how we actually end the thing. I think it computed them right, we just don't get the data back. So I think we can just, let's... So this is how we wait for them to finish. We basically ask the threads that they're complete, which is kind of weird. Yeah, here we go. This is what I wanted. So we want to check the thread. So this is where we actually block, make sure that the threads are done. So for these 0 less than mesh count. I don't know if this is gonna be like really bad. If you like have 1,000 meshes, that might be an issue, but not for now. We might set like a max eventually, but for now, I think the scene that has most meshes is the troopers one, so we gotta check that. And I forgot to benchmark it. We can just keep this code here and compare it. Right, so check thread. What does this do? Yeah, just pthread join. Okay, check thread. Build threads t. And once we're here, we should fetch the actual data. Now we should be done. These calls will block until they're all done. That should make sense. And then think we can integrate it into this loop actually. So meshes t.bvhs build tasks t.bvh, right? So we wait for the thread to finish and then we copy it, right? Just copy the pointer. Maybe that'll make sense. See how bad it crashes now. Okay, it still crashes. Except that now it crashes in computing BVHs. Progress. Let's just run it here. A little bit more feedback. Oh, now it didn't crash. No, it did. Build bottom level BVH. Okay, so what is this? Not thread safe. Reading from vertices, that should be fine. Okay. Do we have like I make this a bit wider. Task poly count. Do we have a mesh with that many polygons? Yeah, I think that's the Venus one. Ouch. What is that? The poly count? Grip F. 274. Venus scaled? Maybe that's garbage data then. Does this make sense? So we set up the task T, then we build the thread, set up the thread, and then we start it right away. Because, again, originally I was going to put these in separate loops. I think this should work. Let's see what happens here. So we start this up. Tasks, yeah. Kind of interesting how it jumps around like that. Let's print 0 just so we make sure that's right. Okay, BBH, yeah, null. Oh, wait, hold on. Yeah, we're copying and yeah, we don't need to do this. We don't need to do that. I forgot about that. Okay, what happens now? It still crashes. Okay. This does not look like it should be not thread safe. These are all just reading from global arrays. Okay. That looks fine. Let's see what happens here. Again, with the, is this a different value than before? Yeah, it is, right? 319808. What happens now? Oh, it's the same, okay. But, is the first one, first polygon, is that? Yeah. Yeah. I don't think we have that many vectors in this thing. Yeah, that looks like garbage data. Let's look this over again. So we set up the tasks. We copy the, we're just copying the pointer, right? And then the poly count. But just, yeah, it's just a straight up value. Yes, okay. Maybe we ought to split these up into separate loops. I don't see why I would have to though. What is with this? Failed to create. Okay, let me look at this again. What if we just don't start the thing and then we pause like here, just to see what we get. Task 0. Okay, that doesn't look right. That doesn't look right. That doesn't look right. Task C. This is not, because C meshes. I don't think this is right, because we don't actually allocate. That's a null thing, right? We haven't allocated it yet. Yeah, let's not do this. That's not, and then we're going to do this. Meshes t dot bvhs tasks t dot bvh, right? Because that's just asking for trouble. Let's do the first one. Okay, the polygons again is null. That's not right. Are we? Wait, we're here. That explains it. Okay, well, it still was valid. We were basically setting an initialized pointer there. Okay, and that doesn't look. Wait, hold on. There we go. There we go. Now we have some poly count 2. That's the. We can actually look at the HDR. They're in order, basically. So I have the grid plane, which is just a plane. That's 2 triangles, and the Venus scaled. That should be like a couple 100,000. Well, 274,000. Yeah, that makes sense. Bunny. Yeah, 69,000. Nice. Teapot white. Yeah, that makes sense. That's not enabled. Yeah, we should get garbage data from now on. I think, yeah, polygons, that's a pretty big, yeah, this is garbage data, right? Yeah. And then count is like 4, right? Yeah. Okay. Let's try and run this again. See if we may have fixed something. We'll just stop it right there before we actually get to. Okay, it still crashes. What is let's print the polygon. What is the I? I is 0, poly is I. Again, we get a crap polygon. That's not valid data. We don't have that high indexes. This is like, what is that? 4.46 million? No way. Interesting how they're all like X, Y, Z, or the third one. That's kind of neat. B-box and center. User data, which comes passed in. Polygons, yes. Let's see here. Still garbage. What about here? Still garbage. Where's the address? Okay. Poly count 319,000. So we're not setting that right at all. Why are we not setting that right? Let me get back to what we were. We shouldn't need to do that. Yeah. Yeah. What about here? Are those not set up right? Poly count 2, that's right. And then once we've set up, we'll just make sure that the data is set up right. There we go. So, mesh 0. poly count, then tasks 0, oops, poly count 2. Okay. Oh, we wanna okay. Operand tasks T user data. This is just the void star, right? Yeah. Oh, we need to cast that to a void star, right? Arithmetic pointer. What? Maybe we need to wrap that. Hold on. What was it before? We're just taking the address of that. What is that? Okay, yeah, that makes sense. T-pasks. Oops. Let's see. Build threads 0 dot user data. Okay. That is the same address. That's good. Let's get this out of here. There we go. Okay, so we can get it out of there. That's fine. But why is it not good there? It would be helpful if mesh count was 1. So let's just set that for now. So we'll just do it for the first one. And okay. Maybe there's something super obvious going on here. Did it just work? No, it did not. Okay. So let me just put this here and get the crash. Cool. Okay. So thread stub. Build bottom all BVH. Is there any details that we could just like gawk at and render? I'm not completely. Yeah, we do the same here, right? 3T, we set it up. Set up the thread. And then start the thread, right? So why is this not right? Yeah, it gets like corrupted along the way. Why does that happen? Maybe we're extracting it incorrectly. So here we get thread. Thread state. Oh, yeah, we are extracting incorrectly. Oh, I forgot about that. Maybe I should build like a helper for that. That is not right. Hold on. Yeah. So we need to extract the thread first, and then from that we get that. Yeah, okay. That's my bad. Yeah. The arg, if we go thread C, we pass in arg, which is, hold on, arg. What do we pass in? Yeah, we pass in the 3T itself, the CR thread. So we need to get it from that and not from, yeah, okay, so that's my bad. So struct CR thread thread is, what is it? Struct thread arg, and then task is thread leader data. That should have been obvious, but evidently not. I think that should work now. All right, cool. Let's make it not derpy now. So, get rid of that. That's fine. We'll let it all run. Maybe that'll work. Pages. Cool. Okay. So now let's rerun that. See how long that takes. And for 20 milliseconds. Well, in this case, there might not be that much. 448. That's not bad. 420. It's definitely faster, for sure. We could do like a couple of runs. So we'll do like a couple of runs here. Let it get warmed up. 3, so it's like 410, 423, 410, 423 plus 420, divide by 3, 417 milliseconds. And then if we go for the old one, where they're, see, because in this case we had like one really big mesh, which will take a long time, and then, you know, really small meshes. So the speed up's not great, but if we have a lot of big meshes, this is going to speed it up a lot. So now we're going to run with the old one. But I think it's working. 426, 421, 413, 421, 426, and the old one was 417. This is 420, so it's a very slight speed up. Let's try with the trooper scene. So this is now with the old one. Alright, pull on troopers. Unzip the trooper. So this is like an, actually, yeah, this should work. It actually might not. We'll see. Yeah, we don't get anything because we forgot to. I think we have it in input. Oh. Yeah, we do. And the settings are all wrong. Let's do D1280 by 800. One sample. There we go. So there's a trooper scene. BVH building was 326 milliseconds, so they're not huge meshes, but they're all the same size. So 326, 330. So what is it? I'm just looking at the building BVH's time. So 326. 326 plus 330. 330 divided by 3, so that's 328.6. So it's like 328.6 milliseconds old. And then actually the new one, we need to actually start the timer. I don't know where the time came from before. What? How did we ever get the time? Because I think I was looking at the wrong one. I actually don't know what happened there. 448. Yeah. We didn't even print it. I was looking at the scene. What was I looking at? I think I was looking at the render time. And it just happened to be similar. Yeah, I was looking at the render times. That just happened to be... Yeah, okay. My bad. Okay, this is why you don't code it, you know, this time of hour. Let's actually start the timer now. So we'll comment out this. And we'll copy this guy. Uncomment this. And then print some more time. And print new line. Right. So this should be now valid. Okay, so that's the old one. Then we'll just run this a few more times. 3 more times. Yeah, 90 milliseconds. That's way better. That's actually more like what I was expecting. 92. That's brilliant. That is a huge reduction. Because it was taking like noticeable time before, 330 milliseconds, and now it's taking 90. Well, we don't even need to compare it. It's like 90, 92, 90. So that is a big reduction in time there. That's great. Let's run the... So it was 317 for the old one with the HDR scene. Let's run this again, but for the... like this. With an actual timer. What is this now? 399, 399, 422. Okay, that's a bit of a discrepancy, but I will go with it. 422. Again, with this, it's a one slower. let's rerun those. 406. It's possible that it's slower because we're doing a bunch of setup, but it wouldn't be that much slower, would it? Here we should go through like that. Maybe that's like a fluke. 422. 400. This is not really a good test scene for this, honestly. Troopers is much better because we have multiple large meshes. And before it was running at, you know, one after the other. It was basically repeating work. Well, not repeating, they're unique, but still, it was running one after another. So I think this is a pretty good result. Let's just make sure that we actually made it faster and this is not just a fluke. So let's do this a few more times. 90 milliseconds. And 324. I'm going to consider that a win. Yeah, that's a win. Let's clean this up. Make a commit. So we can get rid of this. And I was actually wondering earlier about like how good it is to use. How good it's going to be to use the CR thread. Well, this abstraction for other things, because right now I'm only using it in that one place, you know, renderer.c, you know, to set up the threads. Where is it? Yeah, here. But it's not that bad for setting up, because I haven't made like a task system. But this is not too much boilerplate to set it up. What did throw me off was this, you know, getting the thread. So let's see, what is in a CR thread? We got the thread user data. So we really don't need this, do we? We could basically hide this, but let's make a commit first and maybe we'll clean it up. It's getting really late, so I might not do that tonight. Let's clean this up, get rid of the spaces. I always like putting a lot of space in between like different blocks to keep like, I don't know, different contexts. Computing PVHs, and the log actually looks alright. Run that one more time. I mean, this is all the testing I do, basically. I just run it a bunch of times and hopefully it doesn't crash. But that is a good one, because if you want to do animations, you have to invoke C-Ray over and over again. It has to reload all the assets. It's not great. I had to work on that. I had to make like an interactive mode, but this is a great boost up if you want to do like animations using scripts for now. But it's going to be nice in the future. I mean, we're saving a lot of time there. You know, the whole scene warm-up time went from 753 milliseconds to 505, so that's a really good reduction. 250 milliseconds gone. So it's just making sure that the log all looks right. Yeah. And then we gotta free these, right? Tasks, free, build, reds. Are we doing anything else weird? No, we're just copying the stuff over. Yeah, that's all good. What else? I think that is it. We can remove this comment, for we don't need it anymore. 104. So there's flukes if it taking slightly bit longer, but that's normal variation on a system like this. We can remove that comment. I do wonder if there is like a issue about this. Let's see. Parallelise. There is not. Yeah. Okay, that's fine. Yeah, just making sure I didn't mess anything up. Because in the past, like yesterday, I made the video, I kind of messed some stuff up because I pushed too quickly. One thing I do want to do is add like a helper to just directly get the user data and maybe hide the actual struct. We'll push this first. So we got some other changes that we don't care about. Scene.c this is, scene.c, yeah. We don't care about that one. What file is that? Print scene stats. Oh, hold on. Let me look. Oops. Oh. That's the one I was looking for. Let's see here. Scene. It's just easier to stage. We don't care about. I was working on making like locales set up, so you actually see the dot separators for these large numbers, but we don't need that. That's easy to do later. Don't care. Don't care. Yeah, okay, so we staged this. What else? Yeah, that's just the meme. Okay. Parallelise what? BVH building. Test JSON, which by the way, we need to publish a new version of that. And I can show you that in this video maybe. Managed to reduce BVH build times from, what was it again? 300 something? 93. Where's the last test? Troopers, 90 milliseconds. 330 milliseconds to 90 milliseconds. Yeah. The top level BVH is still built using a single thread, but that makes sense. There's only one top level BVH. So that's good. We spawn as many threads as we have meshes and just compute them in parallel. That's brilliant. Okay, I like that. We need to yeah, I guess that's simple enough. Hopefully that doesn't break anything. Directly to master. Let's look at the thread.h here. So in a Sierra thread, we have the user data and then we have the thread ID. Do we use that? So in like render thread, so we get the user data. Thread. We don't use the thread anymore. Thread state, yeah. What about in here? Thread num. That's again thread states. We can hide that. Oops, not .g. We could just put this in the implementation. And this is not relevant anymore. Let's put this in the implementation here. Just we need to put it before this. It's gonna break a bunch of shit. And then we can get like, where do we actually care about this? Okay, so we care about the size of the thread. Okay. So we can just make a new function. Thread amount or thread count. Thread amount. Threads. Naming, man. Okay, start thread. These are not in the right order, but whatever. Oh, and we have the if-def stuff. Return, catalog. Whoa, do we not? Okay. I think catalog is just in string, right? Where's catalog defined? Where's that? malloc.h? But what is this header? malloc.h. Maybe it is malloc.h. That's not a thing. I guess it's in stdlib then? Catalog, there we go. There we go. And then what else? Then we want to get the user data, right? Right, so void get thread user data pointer. Whatever. It's a bunch of, you know that. How do we actually fetch this in here? So we get okay, so yeah. Actually, yeah, this is gonna be void. And then we're gonna do the same thing as here. Maybe yeah, and then turn thread user data pointer. Okay. Thread. There we go. So now we don't have to do all this crap. We just do thread user data. Oops, actually the task is going to be like this. So get thread user data arg, and we don't need this crap. And then, ooh, yeah, we just need to build like a constructor for that. Build threads, threads mesh count, and then for this one we're gonna what should we call this? Oh, actually, hold on. We can't have this by value, can we? That's gonna be a problem. So here we know the size, and we can just do the, whatever this is called, designated initializer. And that's fine. But why is it not like that? Start thread. We could use the create threads and give this. Do we ever want to have a different one? Yeah, we do. A task needs to be different. You know what? We can actually just do like a set user data and set thread func. Yeah, that's what we can do. We need assertions here. Hold on. Assert t assert user data. I don't know if this makes sense to verify it like that. We'll just assert that. You should never actually, give a null here. And then void set thread func. And the thread func always follows the same format. So struct thread t, and then it's gonna be a void star. Hold on. Did I get it right? I did not. Hold on. Let me cheat. Yeah, name, parameters. Okay, and that's the name. Yeah. And it returns it. Yeah, void. Yeah. Okay. Assert t. Assert thread func. We don't want to pass a null. Thread func. Oops. Cool. That makes sense. I put these in the header. Just clean this up. There we go. Then here we will just build set user data build threads T, and then that's gonna be tasks T, right? Build threads T. We'll worry about that in just a second. Set thread func build threads T, and then oops, and then it's gonna be like like that. Then we can get rid of this. In subscript of pointer to incomplete. See, this is pointer, right? Set user data takes a pointer to a CR thread, and then our subscript of pointer to incomplete type. Oh, because it doesn't know. It doesn't know the size of a thread, so it can't subscript, of course. So build threads, so we need like a get thread function, right? Okay, we'll see if this makes sense. So we're gonna need like create threads, and then hold on. Yeah. Does this make sense? I don't know if it makes sense, but we'll see. Create threads. Threads X like that. The address of that. That's fine. That's gonna be build threads and T. And then this is gonna be void cast. Actually, let me take the address of that. Okay, there we go. Maybe this is starting to make sense, or maybe I'm just making it worse. I think I might be making it worse. We'll see. We'll compare it before and after. Okay, so that's what it looks like. It's now hidden, which means we can't use this nice syntax for building it. So it's less consistent, and I don't know if I like that. This doesn't look right. Okay. And yeah, it's a bit less consistent. We'll see what it looks like. And then here. Okay, so we're gonna have to do like happy about that. Expected. What? We need extra that one. And then set thread func or get thread. Yeah, this might not be nicer. T, and then we're gonna set this to render thread. user data. And this is going to be our state thread states of t. It's going to be like the address of that, I guess. Will this even work? We'll see. My bet is on that it's going to crash, but we'll see. State threads t. No, not like that. It's probably not cleaner. Maybe this doesn't make sense. I do like to get user data though. That one is a nice helper. We'll see. How does this look? Thread state is gonna be get user data. There we go. And it's gonna be casted to, in this case, struct under thread state pointer. Now we don't need the thread thing. Maybe I got a little bit too excited here. Maybe. Just maybe. Okay, that builds. I'm gonna guess it's gonna crash or something. Is it nicer? I'm not sure. Shock. It actually works. Let's look at the diff. Right, we managed to hide one struct, but we added 5 new helper functions to get done what we did without them before. This is the hardest kind of question. It's like that of design. It seemed nice when I started working on it, but really what I wanted was the get thread user data function, like that helper, right? And that's it. Do I want to commit this? There's a lot of changes. There's no real point in hiding this, really. I think we're just gonna keep get thread user data and ditch the rest. 'Cause there's no really like a real reason for hiding this. Before you could just create the data and use it, which is like simple and nice. And yeah, this is like, yeah. I'm looking at the end result and it's not better, it's just different. Doesn't jive with me. Okay, we'll just yoink these out and undo that. Well, we learned something. I don't like that design. If you think that there's a good reason for hiding the struct, then do let me know. I'd love to like hear different opinions on this. So really, we all only just wanted the get thread user data stuff, you know. Discrete lines, thread.h, thread.c, yes. So user data, let's discard these. It's not that hard to clean it up, it just, yeah, discard lines. Then here, yeah, we discarded that. Reset. And it should build, yes, yeah. But now we can do like data arg, like that. That's all I really wanted. And actually, I want to rename that as well. I want to really name these all. Okay. This is the kind of finagling you gotta do to, what did I rename it to? Thread user data. Right? Thread user data. And the same for pvh build thread. Thread user data arg. There we go. I don't know how long the stream is, like 30 minutes or something. We learned something at least. There's a lot of this kind of, I start building something, there's a lot of changes, and then I just decided it's not better, it's just different. I kind of wanted to see how the end result looked before I decided to abort that. What else did I want? Yeah, I wanted to rename the other functions, right? .h. We might actually commit this helper though. First, let's do that. Make sure it still builds and works. Yeah, that's cool. What was this? Thread to get user data. Cool. Help to get thread user data pointer. Ditch that hunk. I should ditch this. Ditch that. Okay, cool. What else? That. Yeah. Okay. Anything in here? Yeah. Push that. Maybe I've broken the build and I just didn't notice. Maybe. It's a pretty common thing. Yeah, it actually built. Cool. Let's rename those functions, and then we're going to be done for tonight because it's really late. So usually when I want to do like a header, so let's look at vector.h. They all start with vec. So vector with precision, vec0, vec add, vec sub. I want to stick to that more. Not all. This also deals with coordinates, which is just a 2D vec, which really, yeah. Vec cross, vec min, may have to split this into a different file, but whatever. Okay, well, there it fails. Yeah, well, mostly. I tried to stick to that. Doesn't always happen, but for this, I wanted to start with the name thread. So thread get user data, thread start. Can I just refactor this? Xcode's refactor tools usually don't work that well. There we go, okay. Thread start. There's usually some bug, so thread check. We should, what does this actually do? It calls thread join. What should we call this? Thread wait? Because pthread join never really sounded logical to me. Thread wait. See, now it's looking for all the occurrences. There we go. Thread wait. Okay. Yeah, block until the given thread is terminated. Platform abstraction thread. Do you really need to be explicit? Whatever. Thread start. Spawn a new thread. Sounds like we're creating it. Start it like that. Yeah, maybe that makes sense. It builds. I think that's it for tonight. We managed to make it way faster in certain workloads. I think that's good. Let's commit this and then we're done. Let's put this like this. Yeah. I want to discard this hunk. I made it so that if it gets to 69, it's, yeah, okay, let's discard that. Put this in, and that one. What's in here? Yeah. Rename thread functions to always follow the form thread star. Okay. Commit and push this. I've used Source 3 for a couple years. I've tried to get to like the terminal workflow, you know, interactive staging, but this is just nicer. For some things, a GUI still makes sense. Okay, that's good, I think. We'll just wait for the CI to finish. We don't have to wait. Basically, it just builds it. That's all it does. It doesn't run the tests. In fact, we haven't run the tests now, but there's like only 8 of them, and 3 of them fail. I made a super simple test runner that just runs through the tests.h. Just list them here. There's 6 tests, and I think these all fail. These 2 fail. But whatever. They all run inside the main process, basically. We just build it with the test. Yeah, we've actually built it with tests enabled, so there you go. Pass. And then it crashes. Yeah, that works, maybe. Yeah, it passes. I think that's it for tonight. If you watched all the way through, thank you very much for watching. I hope you found something interesting in this video. If you have any ideas of how I could do things better, please comment them down below. That would be awesome if someone spots something that I could do better. Obviously, we went through a bit of a hoop here, trying to refactor a bunch. But that's what happens. This is kind of the real workflow. I do a lot of this refactoring just to see how it would look. But yeah, that's it for tonight. Thank you very much for watching, and goodbye.